Okay, for this problem, I think it's essential that we understand the context of the question. We are given a matrix P, and they tell us for juice X, we need different numbers of different fruits. For juice Y, again, a different set of numbers of different fruits. Apples, oranges, and kiwis. And in January and July, the prices of the apples, orange, and kiwis, they cost a different amount. So in part A, they ask us, they give us two matrices, P and Q. They ask us to calculate PQ. Describe what is represented by the elements of PQ. I have done the multiplication here for you already, but PQ is evaluated here for you to see. But how exactly do we interpret PQ? I showed the working specifically to let you see. This really, if you can see, this is juice X. This row is juice Y. This is X. This row is juice Y. Okay, and this here is actually the price in January. This whole column here. This column on the right hand side is actually the price in July. Write that down. So these things are not stated, but you figure out because, look, this is juice X. I need 5 apples for juice X, multiplied by 45 cents, and 45 cents is the price of an apple in January. I've got 7 oranges, multiplied by the price of each orange in January, 50 cents, plus 3 kiwis, multiplied by the price of a kiwi in January, which is 55 cents. So I go on and on. So this will be for July. You can check the numbers. This is for juice Y in Jan and juice Y in July. Okay, so we get PQ, and in short, I won't write it down. PQ represents the total price of juice X in and juice Y in January and July. You can indicate down here. This is for juice X, juice Y. We're looking at the total price in Jan and July. So even though I'm using a matrix and a matrix doesn't have headers and labels, I'm quite free to edit my own just to help me to understand what I'm doing. Okay, so this completes part A. For the next problem in part B, they have very kindly told you what R is, 10, 10, and they've actually told you this is K, beg your pardon, K equals to RP. They've actually told you what K means already, the number of fruits of each type needed to make 10 glasses of X, 10 glasses of Y. And we see that at work because we did 10 times 5, so that's 50 apples, 10 times 4, 40 apples, and that's for juice X, juice Y. So I needed 50 plus 40 apples to make 10 glasses of X and Y, and we added them together to get 90. So this is 90 apples to make 10 glasses of X and 10 glasses of Y. 120 oranges to make 10 glasses of X and 10 glasses of Y. 90 kiwis to make 10 glasses of X and 10 glasses of Y. So that one is very nicely explained for you already. For the last part, this is part C. Oops, I didn't write it. This is part C. KJ. We are making use of the K from the previous part. This is K. Again, to refresh, this is the number of apples, number of oranges, and number of kiwis to make 10 cups of X and 10 cups of Y. So apples, oranges, and kiwis. I'm going to multiply it effectively by the price of each apple, number of oranges multiplied by the price of each orange, number of kiwis multiplied by the price of each kiwi. But this is in January. If you look at your table, these are the prices in January. So take a moment now to evaluate the product. And if you evaluate the product, you will find you actually get a matrix with one element. It's just one number, but it's still a matrix. Okay, so there's one element in KJ, and this here shows the total price. Let me try to write it out. The total price of making 10 glasses of X. I'm just going to write 10X and 10Y. So 10 glasses of X and 10 glasses of Y. I take all the fruits, right? I found all the fruits and multiplied it by the price in January, and I got the total price. But remember, this is in January. If we were to find out the price in July, then this matrix would change to 50, 55, and 70. So this concludes this problem.